Advantages of linked lists. Linked lists offer several advantages that make them suitable for certain applications. Here are some key advantages of linked list. Dynamic size. Linked list can easily grow or shrink in size during runtime. This dynamic sizing makes them flexible in handling data structures where the size is not known in advance. Efficient insertion and deletion. Adding or removing elements in linked list, especially in the middle, is more efficient compared to arrays. It involves updating pointers, and there is no need to shift elements as in arrays. No pre-allocation of memory. Linked lists do not require pre-allocation of fixed size block of memory. Nodes can be allocated independently, and new nodes can be added as needed. Constant time insertion or deletion at head. Adding or removing elements at the beginning of a linked list is constant time operation. It only involves updating the head pointer and the next reference to the first new node. Ease of implementation. Implementing linked list can be simpler in certain cases, especially when dealing with the dynamic data structures. There is no need to worry about resizing, and inserting or deleting nodes can be without complex memory management. No wasted memory. Linked lists do not suffer from the wasted memory due to the pre-allocation of a fixed size block. Memory is used more efficiently as node only requires space for data and references. No overhead for resizing. Linked lists do not incur the overhead associated with resizing, which can be concerned with dynamically resizing arrays. Constant time concatenation. Concatenating two linked lists can be done with constant time by adjusting pointers. Unlike arrays, where concatenation involves copying elements from one array to the another. Support for various types. Linked list can be easily adapted to support different types of nodes, such as singly linked list, doubly linked list, or circular linked list, based on specific requirements. Ease of building other data structures. Linked lists provide the foundation for building other data structures, such as stacks, queues, and symbolic expressions. Linked lists are particularly advantageous when there is a need for dynamic sizing, efficient insertion and deletion, and flexibility in managing memory. However, the choice between the linked list and the other data structure depends on the specific requirements of the application.